Hello, and welcome to Promode's Code Crafter. In today's video, we're diving into a fascinating topic, operating systems support for virtual reality, VR, and augmented reality, AR. We'll be looking at how operating systems play a crucial role in making these technologies work seamlessly. So, let's jump right in. Introduction. First, let's start by understanding what AR and VR really are. Augmented reality, or AR, blends digital elements with the real world. A popular example of AR is in games like Dark Sword, where digital characters or environments are projected into the real world. On the other hand, virtual reality, or VR, is all about creating an entirely immersive experience, like in virtual gaming environments or simulations. VR shuts out the physical world and makes you feel as if you're part of a completely different digital space. Both technologies require significant computing power, which is where operating systems come into play. Now, you might be wondering, why do we need to discuss this in the context of operating systems? Well, AR and VR applications are incredibly demanding. They require real-time processing, meaning the operating system has to handle tasks immediately, without delay. OS also manages system resources like the CPU and GPU, which are crucial for high-performance graphics in AR and VR. Latency is another issue. If there's a lag, it can totally break immersion, especially in VR. So, the operating system needs to be highly optimized to ensure smooth experiences. Also, as AR and VR applications collect a lot of personal data, the OS must ensure that this data is secure. In this case study, we'll explore how different operating systems support AR and VR technologies. We'll look at the challenges faced, like real-time rendering, memory allocation, and input management. We'll also cover some of the modern solutions that have been proposed to optimize performance and enhance user experience. Here's the problem we're tackling. VR and AR require significant computational power. High latency can ruin the immersive experience. Limited memory or CPU resources can lead to performance bottlenecks. Another challenge is real-time data synchronization, especially with multiple sensors and user inputs. Our goal in this presentation is to analyze how modern operating systems are designed to meet these challenges head-on. Let's take a look at the methodology. We'll begin with a review of existing literature on how operating systems manage real-time processing and resource allocation for AR and VR. We'll also conduct a case study on specific operating systems, like Android and Windows, to see how they handle AR/VR workloads. Finally, we'll analyze existing simulations or real-world tests that show how OS behavior affects performance in AR/VR applications. Based on the analysis, we found that an operating system's role in scheduling tasks is critical for AR and VR performance. Tasks need to be managed efficiently to reduce latency. Hardware acceleration, especially through GPUs, is crucial in handling the complex graphics required by AR and VR. For example, Windows Mixed Reality and Android's AR Core are two systems that have developed strong support for AR/VR applications. Another key finding is how operating systems are improving task scheduling and memory management to meet the demands of these technologies. Here's a diagram that shows how an operating system interacts with various hardware components to support AR and VR. As you can see, the OS manages the input from devices like motion sensors and cameras. It processes this input in real time and coordinates it with the CPU, GPU, and memory to generate the output, which is displayed on your screen or VR headset. This entire process has to happen without delay to maintain immersion and realism. In conclusion, operating systems play a key role in the success of AR and VR technologies. They ensure real-time processing, manage resources like memory and graphics processing, and handle multiple data streams in real time. Looking forward, there's still room for improvement. Future developments in OS design will likely focus on reducing latency even further and improving resource management. This will be crucial for the next generation of AR and VR experiences. Thanks for watching. If you found this video helpful, don't forget to like, share, and subscribe to Promode's Code Crafter. Thank you for staying with me until the end. I hope you enjoyed learning about operating system support for VR and AR. As a special treat for making it this far, here's a short gameplay clip from Dark Sword, which ties into some of the key concepts we discussed today, like real-time processing and smooth rendering. Let's see how these OS optimizations come into play during the action.